So welcome to the first day of class for CS 891, 3891, or 5891, depending on whether you're taking it as a grad course or undergrad course. I'm Doug Schmidt. I recognize lots of faces here. Welcome back from the break. What we're going to do today is I'll give you an overview of what we'll be covering in the class, and then we'll start launching right into the first set of material. The website I'll talk about, it already has the first programming assignment up, as well as a video describing the elements of the first programming assignment. So the thing we're going to cover today will basically be what is the class about and what you can expect to learn in this first session. So first, kind of a motivation for the topics we'll be covering. The course is nominally titled something like Concurrent Object-Oriented Programming with Java and Android, and it's a companion to another course I teach, which is Parallel Functional Programming, which some of you guys have taken already. There's very little overlap between the two courses. In fact, really no overlap whatsoever. So it'll give you a chance, if you take both courses, to get a real deep view from soup to nuts, from beginning to end on these exciting topics. And why these topics are so exciting is that there's an increasing demand for people who know how to take advantage of concurrency on modern platforms. And this includes things like mobile devices, and servers, and cloud computing infrastructure, and so on and so forth. So a lot of things these days have a need for the topics we'll be covering. Why is that? Well, one reason for that is that there's been a proliferation at the hardware and system software level of support for things like multi-core processors. So if you've been following the trends over the past decade, maybe a little longer than the past decade, the concept of Moore's Law, where for years everything tended to get about twice as fast every 18 months or so, that kind of petered out a while ago. It petered out in the early 2000 timeframe. And so what's happened instead is that Moore's Law still works. Moore's Law says that every 18 to 24 months we get double the transistors available to us. But rather than making things run faster, what we do now is we have more hardware processing cores. And so the question then becomes, how do you take advantage of that stuff? And this class will give you one perspective on how to do that. The other class gives you a slightly different perspective. The other motivation for the topics we'll be covering here is that mobile devices are typically designed to have a special thread, we'll talk more about threads shortly, called the user interface thread, and that's what interacts with the user, as the name implies. And if you want to do long-running computations, you want to download stuff from the web, or you want to do some kind of time-consuming processing or computation, you do it in one or more background threads. And we'll see that this way of structuring the code to have the user interface thread be very responsive and the background threads be capable of blocking and other kinds of longer-running computations is very, very common today in mobile device programming. And a lot of what goes on in the world today involves mobile devices, so understanding the use of concurrency in that context is a big motivator. And in fact, that's one of the things we'll be focusing on throughout this class, is using the topics and concepts and programming features we're going to learn and applying them in the context of mobile device programming. It's been my experience teaching these kind of topics for a really long time that just sort of thinking about this stuff in the abstract with the theory and the concepts, while always useful, it's always good to have that kind of foundation, is really inadequate to firmly grasp how to apply these techniques in practice. So sitting and thinking is not sufficient to really become an expert at concurrent programming. This is not a theory course. This is not like the algorithms course where you spend a lot of time analyzing code abstractly with various computational models. Instead, what we're going to do is get a lot of hands-on experience programming and getting a chance to really apply these things in practice. So you'll get a chance to read and write concurrent code. You'll get a chance to maintain and modify concurrent code, and you'll see how that's going to work because we're going to build some things that'll evolve over the course of the semester. And you'll also get a chance to learn how to optimize the code so it runs effectively. You'll get, hopefully, some chance to learn to debug concurrent code, which is a challenge in its own right. And to that end, we will provide a whole bunch of automated testing examples and testing suites you can run to increase your confidence that things actually work well. And part of this will also be not just learning the mechanisms, but also learning the patterns of effective programming of said mechanisms, which is really important. So there'll be a lot of hands-on development and running of tests and so on. So here's what we're going to cover. The bulk of the course is going to focus on foundational Java concurrency mechanisms and a little bit of Android stuff thrown in for good measure. We'll talk more about that in a second. So the Java stuff, which is really the bulk of the course, is going to focus on various threading models. That's my little thread icon, as well as various synchronization mechanisms that can be used to coordinate and ensure exclusive access to shared resources. And we'll be focusing here on Java 8 and earlier techniques. And this will all be applied in the context of the Android platform, which, for better or worse, is currently suspended in time at Java 8, even though I think we have Java 13 out for other platforms. But the good news is that the Java 8 features are the key ones that we're going to be leveraging. We'll also be talking a lot about patterns and frameworks for concurrent programming, focusing primarily on the object-oriented patterns and object-oriented frameworks available in Java and Android. And you'll see there's a whole ton of them. We'll be focusing on the frameworks, of course, in order to be able to reduce the amount of time required to write applications, because you can leverage what's in the framework. You can take it off the shelf and customize it. And we'll also be talking about patterns to give you a deeper sense of how things work under the hood. If we have time, and I think we're going to have time because I'm a big fan of this topic these days, we're going to spend a little time talking about a newer technology platform called Kotlin, which is primarily used these days for Android programming, although it's a more general purpose language than that. And when we do this, this will probably be towards the end of the course, we'll focus on something called structured concurrency, which is basically using a technique known as coroutines. And so I've been having lots of fun lately learning about Kotlin, and so we'll probably get a little chance to work on that. I'm not going to crush you with Kotlin, but Kotlin is pretty cool, and it basically, it kind of does for Java what Swift does for Objective-C. Makes it a little bit easier to program. It's Java-like. It runs on top of the Java virtual machine. You can use all the Java libraries with Kotlin quite easily and all the other stuff we're going to learn. But it kind of takes away some of the complexities of programming. So we might get a little chance to work on that. And then, of course, because I'm a big fan, we'll be doing patterns all over the place to kind of underlie this. I'm assuming, and I will help you with this, that you can pick up things like Android Studio very quickly if you haven't worked with it. Anybody who took the course before from last semester is going to be well versed with that. You'll need to know a teeny weeny bit of Android, not really a whole lot, but you'll have to understand how to run things in the context of, say, the Android emulator. You'll have to figure out a little bit of Java 8. Again, nothing too complicated. This is not really pushing the boundaries of Java 8, but you'll need to understand quickly things like Lambda expressions and method references, if for no other reason than to read the examples that I use in class. If you take a look at the email I sent out to everybody before class, it gives some tips on where you can learn more about these things. And you should also know how to use Git, and we'll, of course, help you with those kinds of things as well. OK, so let's just give a quick overview of the different topics we're going to cover. There are 4 main things we're going to go into. The main focus, as I said before, is Java and Android threading and synchronization. So threading will give us a chance to learn about Java threads. In fact, that's your very first assignment. Assignment 1A, I'll talk more about what that means in a second. And that'll be involved by programming very simple use of Java threads and other things that relate to threads like runnables. And then we'll also be talking about the various frameworks that are part of the Java executor framework. These are essentially thread pooling frameworks. So we'll talk about Java executor, Java executor service, Java scheduled executor service, Java executor completion service. Those are the things you will play around with, and you'll get a chance to use those in the assignments you're doing. We'll also spend a little bit of time talking about the Android handlers, messages, and runnable, or Hammer framework, and the async task framework. And we may or may not have a time to program an example with that. This is particularly useful if you're programming with Android. But because Android is moving increasingly to Kotlin, we might substitute the Kotlin coroutines and structured concurrency part for that. We'll see how it goes in terms of the time. We'll also spend a lot of time on synchronizers. So threads are basically units of execution that can run on one or more cores. And synchronizers are the means and mechanisms for coordinating the access to shared resources by multiple threads. And so we'll talk about some of the basic Java synchronization mechanisms like built-in monitor locks and monitor objects. And then we'll talk about a ton of synchronizer classes in Java util concurrent. So reentrant lock, condition object, semaphore, and then some of the concurrent collections. And you'll get a chance to play around with all these things in the assignments. As I said, we might have some time, I think we will, to do some structured concurrency with Kotlin, which is going to be lots of fun. I should also hasten to add that in future versions of Java, the concepts of structured concurrency that Kotlin is pushing at the moment are very likely to become integrated into Java in the not-too-distant future. So the good news is that once you understand the concepts, it'll be easy to use these in multiple languages. And then, of course, we'll talk about things like concurrency patterns. And you'll get a chance to find things like active object and monitor object and all these other good patterns. We may bounce around a little bit as we do this stuff. And the whole reason for bouncing around a little bit is to make sure that we can cover the material needed for the assignments when the assignments are due. You'll also see when you read the assignment descriptions that I always put links to videos of all the topics that are needed to understand to do the assignment. So even if we don't get to them in class by the time the assignment is due, you can watch the videos. And I always record videos for everything I do. OK, this is just a minor point. We have lessons. Lessons have parts. Each part's a lecture. I will put the PDF versions of the lectures as well as screencasts of my presentation up on my website, which you should be able to go to. And that basically gives you a pointer over to the YouTube playlist where everything will be available online. And there's generally a little discussion at the end of each of the lessons so you can get a chance to think interactively and ask questions and so on. We'll have quizzes in class every other week, so every 2 weeks or so. And this will cover the material we cover in the lecture. For those of you who take the class before, everybody hates the quizzes. But they're a very good way to keep track of like what we're really talking about. Your goal should be, because we have so many resources at your disposal, which I'll cover in a second, your goal should really be to master everything that we cover and feel comfortable with the quizzes. The first quiz will be Wednesday, January 15th. Quizzes and the final, if we have one, more on that in a second, are always closed book. We will try to get everything back to you by the next class, by the next Monday. And one of the nice things of having a smaller class is that I can get to know everybody, hand back quizzes, we can go over them in class. It doesn't have to be a big anonymous affair, which is nice. The best way to study for the quizzes is to look at the slides and watch the screencasts, and of course, ask questions on Piazza, come to office hours. We've got lots and lots of office hours. I'll talk more about that in a second. And make sure you're very well versed in all the topics that we cover. A couple things, people from last semester remember this. I'm a big stickler on coming to class and participating. If you don't come to class, if you don't come and pick up your quiz, you lose lots of points, so make sure you show up. And don't just show up for the quiz. So if you don't come to class and then you show up for the quiz, you lose points. So attendance is very, very, very important here. And we'll talk more about that in a second. There may be I said here will, but there may be a cumulative final. And this always depends on whether or not we have a programming assignment that ends up spilling over into exam week. Depending on how things go in the class, it's sometimes hard to know exactly how long things will take to cover. We might end up having the final programming assignment be the in lieu of the final. We did that last semester. We might do it again. If we finish everything by the time classes are officially done, then we'll have a final. But sometimes the programming assignments spill over, and I don't want people to have to both finish up their assignment and study for a final during the exam period. And I'll talk more about how that whole thing works. If we do have a final, it'll be on April 24th in this room. And remember that engineering finals are always 3 hours long. OK, so let's talk about other things you'll do. So obviously, you come to class, you ask questions, you take quizzes. But really, the fun part is the programming assignments. Everything we're going to be doing is based on Java 8 and Android Studio. So you'll have to get comfortable with that. Fortunately, it's not too hard to get comfortable with this. But you'll need to use the latest version of Android Studio, which I think at the moment is something like 3.5.3. If you go to, I'll give you the instructions in a second on how to get it. I think whatever you used last semester should, if you took my other class, should probably still be fine as well. And you'll use Android Pie, which is API version 28. You'll need to install Java 8, which you can get by reading the link here, which gives you the instructions on how to install the software. And that will work nicely with Android and Android Studio. Android Studio, for those of you who have never used it before, is an interactive development environment. It's very similar to IntelliJ. In fact, it's kind of based on IntelliJ with a few extra cool features that work for Android. And it has a lot of things that we won't necessarily use in this class, but becoming facile with Android Studio, becoming facile with IntelliJ is a good investment because it's very widely used in industry. You use Android Pie, and there's a reason we stick with this particular version because we have all the tests working with that. And so this just eliminates one source of confusion if you're not careful in version skew. So having everybody use the same version makes our lives much easier, and your lives too. All the source code for the assignments and examples are available at my GitHub account, which is basically here. And you'll see that we have the first assignment that's available and some other stuff, which you don't have to worry about right now. And I'll continue to upload things there. There's also a frequently asked questions file, and someone already posted a great question on Piazza asking about how to synchronize the repositories. And so I posted a little diagram or a series of slides with diagrams that show how to work with this stuff. And basically, in a nutshell, what you'll do is you will pull code from my repository into your GitLab repository. And the main reason for this is, back in the day at least, GitHub required everything to be public, whereas GitLab, you could have private repositories. That's changed a little bit, but I think it still makes sense for what we're doing here. So I put all my stuff on GitHub. You basically pull that into your workspace. You do your work locally, and then you push back to your workspace, not to my workspace, back to your workspace, which needs to be private. And then, as we'll see later, I can go in and review your code, and the TAs can go in and review your code and give you feedback and comments. Please make sure you read the instructions I sent out on how to add certain GitLab IDs to add these people as maintainers for your code. That allows us to be able to go in and look at what you're doing. Knowing how to use GitLab is very important, which is just a repository host for Git commands. It's really fairly straightforward, but it's important to master this because otherwise you'll have a hard time following what's going on. Sometimes, every once in a while, something will go amiss and I have to push new things to my repository to fix a bug. This is increasingly rare because the repository and the examples are very stable and the assignments are very stable these days. But learning how to use Git and repository management is important, so you will have to master those skills. It's not too hard. The assignments will give you lots of chance to play around with Java 8 features in the context of concurrency and synchronization mechanisms in Java and maybe a little bit in Kotlin as well. And again, you can get them all here. This is basically what we're going to do. We have this really cool Android app, which I call the Palantir Simulator. For those of you who've seen Lord of the Rings, that's a Palantir. And if you have a group of Palantir, they're a Palantiri. And what we do is we have this cool little user interface that runs on an Android device or an Android emulator. And it basically allows you to have some number of Palantiri, let's say 4. And you can have some number of beings, like 6 or 5 or 12 or whatever. And the beings coordinate concurrent access to the limited number of Palantiri, and it demonstrates all kinds of cool resource management techniques visually. And you can also find it easy to debug your code because if things do weird stuff, it won't work. It'll look incorrect. Things will like gaze forever or won't gaze at all and so on. And so this is a really fun way to kind of make these points more meaningful than just trying to write stuff with debugging output on the console. We're going to play around with a bunch of different mechanisms. We'll have Java threads and runnables as the very first assignment. Then we'll start looking at a bunch of the different executor frameworks. We may or may not do the async task and Hammer framework. We may do Kotlin coroutines. And you'll also learn to apply a whole boatload of Java synchronizers like semaphores, built-in monitor objects, concurrent hash maps, stamp blocks, all these cool synchronization mechanisms. So this will be our vehicle for doing that. And it's really, really fun. You don't have to know everything there is to know about Android to do the assignments, but if you're curious, it's really, really cool how it all works. Now, here's the part that's maybe different from some classes you've been in. Those of you who took the class last semester, this will be very familiar. The way it works is that when you're done with your assignment for the first go-round, you push it to your GitLab repository, and then I go in and review it, and I give you comments. And it's really important that you submit your things on time, or else you get penalized, so don't do that. You can read the FAQ for more about that, but make sure you submit things on time. When you do your initial submission, what happens is that submission is actually not graded. What happens is that when it's initially due, you submit it, I review it, I give you feedback by adding comments to your code, which is why I need maintainer access to your repository, and then you get some time, typically, it depends on how well people did, but if everybody did really bad, I'll give you a week. If most people did very well, you get 3 or 4 days to revise your program as per my comments, and then you resubmit your code by pushing it back to Git in your GitLab repository. And then the TAs and graders go in and actually review it and give you a final grade. So you get a couple chances to get it right. There are also extensive unit tests for the programs, so you get a very good idea of whether you're on the right track. Now, just because your program passes the unit test doesn't guarantee it's correct, because testing only shows the presence of bugs. It doesn't guarantee their absence. But be that as it may, it'll help you a lot, and it'll get rid of most of the silly errors that people can run into if you're not careful and you're still learning the concepts. So you'll get in the groove of this. And I think most people, when I read the comments at the end of the semester, people typically really like this model because you get a lot of feedback and you can learn. And what I also do, which is fun, at least fun for me, after I go through everybody's code and review it, I create a video where I walk through the frequently made mistakes, and anonymously, of course. And then you're encouraged to watch that video and look at the mistakes and then make sure your code doesn't accidentally do any of those things. Usually I will catch the things in your code, but sometimes after a while it starts to blur. And so I may miss a few things in any individual's code, but collectively I'll catch them and go over them in the frequently made mistakes. So that's also a good way to learn where people are commonly making mistakes. And it's interesting with the features in Java with concurrency, you'll see people tend to make the same kind of mistakes over and over again. Okay, you absolutely have to attend class. Heavy penalties if you don't. And so if you don't show up in class and submit your programs, it doesn't matter how good they are, you're going to get penalties. So you can read all about that here, and I'll explain more about this in a second why I do this. Again, very important, this is not a team programming experience. This is a class where we're doing individual assignments. So obviously, please come to office hours. We have lots of office hours. We have office hours every single day of the week. And the people who are TAing the office hours have taken the class before, so you'll get lots of good help if you need it. But make sure that you do your work yourself. And this, of course, goes for the quizzes and exams as well. The most important thing is that your program works correctly. And then there's some other things we look at in terms of consistent commenting style. Another thing that I'm a big stickler on, because if you don't learn it when you're a student, you'll take bad habits later, is commenting your code in a consistent and helpful way. So I'll usually make comments about that when I review your code. Make sure you comment it so you can understand what you're doing. This is most likely the way that we'll end up weighting the class, although there may be a little twist here I'll talk about in a second. So if we have a final exam, that'll be 10% of the grade. If we have that, quizzes and programming assignments are roughly the same in terms of the weight, and then there's a participation part. If we don't have a final exam, then we'll weight the quizzes 45% and the programming projects 45%. So depends. Participation is really important. So there's 2 parts to it. Participation. Part number 1 is showing up. I forget who it was, Mark Twain or someone said, half of success in life is just showing up. So that's how you get half of it. And the other part is to be involved. And you'll see that I'll have ways of being involved through the questions that we have, but also asking questions, coming to office hours, being part of the the culture of the class, posting things on Piazza, those are important things too. So do not forget this. Every semester I say this at the beginning, and people then forget, and then they end up not doing as well as they would like, and that's because they're not participating, so that'll typically knock points off of your final score. So if you don't do anything and sit there like a bump on a log the whole semester, or don't show up in class, it's very unlikely you'll get an A, even if you do great on your programming assignments, because part of the Vanderbilt experience is being interactive and being involved. So don't be shy. All right, let's talk about more technical stuff. For those of you who took the class last semester, this will be a quick review. For those of you who didn't, it's important to understand how to do this. You'll have to install the latest release of Android Studio, which you can get here at this link. And like I said, I think the latest version is 3.5.3. You can probably use 3.5.2 if you need to. It won't make much of a difference. In order to do this, you'll need to install Java, which you'll need to get from the Oracle website. And you want to make, let's see, you want to try to get Java 8. They still have Java 8. They should. So go try to get the Java 8 version of things. Load and install the latest version of Android Studio. And then go ahead and launch it. And you'll have to figure a little bit out about how to select the right API level. You want API level 28, which is Pi. And so if you click that, it'll load that. You're also welcome to load other stuff if you want, but it can get rather resource exhaustive if you download too many versions of things. You'll also need to learn how to create an emulator, unless you actually have an Android phone that works with Android Pie, which is probably not that likely, but if you do, that's great, because it runs a lot faster on the actual phones. The emulators, you'll create one that, of course, will work with API 28, and then you'll be able to run the programs in an emulated mode. And there's a couple little tricks you need to understand to make that work properly. Once in a while, people have laptops that don't have enough processing power or disk space to work properly with Android Studio and Android Emulator. If you run into that problem, do not worry. We will simply, we have some versions of Android pre-installed on the computers that are over on the second floor of Featheringill Hall. So if you don't have a laptop that's got enough oomph, then we can just get you an account over there and you can use that. That isn't preferred because it's obviously easier to have your laptop with you, but in the rare cases where you just don't have enough memory or disk space, that'll serve to work as well. And then the emulator is basically where you would run things if you don't have an actual device. If you have an emulator, if you're going to use the emulator, then if you've got a version of processors that are Intel-based, there are some cool emulator acceleration features that are available to make your emulator run a heck of a lot faster. So this will make it pretty much bearable. If you're somehow using an AMD piece of hardware, then I would recommend using the version of Android Studio that's installed over in Featheringill Hall, because it'll be really slow. So this kind of explains how to do this, and if you go to this link, it'll walk you through it. Makes a big difference. Okay, so one of the other cool things is that all the source code for Android and all the source code for Java is available for inspection. We will look at a bunch of Java source code. We might look at a little bit of Android source code. You can get the Android source code to browse at this link. You can download the Android source code at this link. You can also browse the Java code, and you can download the Java code, Java 8. So I recommend doing that. It's really interesting. There's fascinating patterns. There's fascinating programming techniques. And you can also see how even professional programmers don't comment their code very effectively, which is very annoying. But it's cool to take a look at the implementations in some cases. So to wrap up this discussion, as always, you get out what you put into the course. There's a lot of hard work. I think the programming assignments take time, but they're not, you're not going to spend 30 hours doing the programming assignments. They're fairly confined, and they're intended to teach you specific things. You'll probably actually spend more time studying for the quizzes. Don't miss the deadlines, very important. I'm a big stickler on that. Participate in class discussions. Everything is available on Piazza at this link. And obviously, I'll put these slides up shortly on my website, so you can download that. Here's another big one. No laptops or phones in class unless we're doing something that requires laptops and phones, which we do from time to time. So there's a reason for that. The main reason for that is, and I'm as guilty of this in my real life as everybody else, they're a huge distraction. And in my experience, when people don't pay attention in class, they show up in office hours confused for things that we have covered. And so very important, big rule, lose lots of points, and I just simply won't let you do that. So this is a good time to shut your laptops and please get in the habit of learning to detach for at least 75 minutes twice a week from the world of cyber distractions. Okay, lots of resources to get access to information you need to be successful. My goal is to help you be successful. That makes me very happy. So if you're willing to put the time into it, we're going to have a great time. We have lots of office hours. If you go to the the wiki link on the GitHub account for this, you'll see where all the office hours are held and when they're held. We have office hours every day of the week. We have some textbooks, which you can get if you want. You can probably get most of the stuff online, and you'll see why that's easy in a second when we start going through the slides. We have the Piazza online forum. Lots of Q&A takes place there. All the lectures are recorded, and all the lecture slides have links in them for further reading about all kinds of stuff. Don't feel like you have to go and click on every link in the slides in order to make sense of them, but they're there as kind of a reference if you need a primer or more information. Please resist the urge to email me directly unless you want to talk about something confidential, like if you're struggling with something or you have a broader question. If you have a question like, why doesn't my code compile? Please post that on Piazza, because other people besides me can answer it, and it'll also just get you in the habit of helping each other out. And that's a good forum to help each other out, is the Piazza forum. There are obviously abundant opportunities. I don't think I have to motivate anybody here why being a CS major or minor or CS expert is a great thing these days. For the last several years at least, the CS majors at Vanderbilt have had the highest average starting salary, and there's just tons of opportunities. It's really quite staggering if you take a look at the opportunities for computer expertise in computer programming. And the topics we're going to be covering here, concurrency for mobile devices, are in very, very high demand. And then I'm supposed to put this up. If for some reason we have some kind of an emergency, walk up the stairs and leave the building. So I don't know why they want us to say that. I don't think it would be a big surprise to anybody, but don't take the elevator is the main point.